So, got to multiply this out. So this becomes the integral of sine squared theta plus 2 sine theta plus 1, all that d theta. Now, I'm going to have to use something that you talk about prior to talking about trig substitution. So one of the things that I have is I got to deal with sine squared theta. We don't have really anything to use to deal with sine squared theta because we don't have anything we can use for u substitution. However, we can use a trig identity, and we can use the fact that the sine squared of theta is 1 minus the cosine of 2 theta, all that divided by 2. And now I have plus 2 sine theta plus 1, all that d theta. So just using that fact to help me there. Alright, so this is the integral of, I'm going to rewrite this just a little bit. This is 1/2 minus the cosine of 2 theta, all that over 2, plus 2 sine theta plus 1, all that d theta. So I can combine 1/2 and 1, and that will give me 3/2. So this is 3/2 minus cosine 2 theta, all that over 2, plus 2 sine theta, all that d theta. Alright, so now I can integrate each one of those pieces with respect to theta, so keep that in mind. So integrate 3/2. That's going to be 3/2 theta. Integrate the negative cosine of 2 theta. That's going to become negative sine of 2 theta, all that over 4. Integral of cosine is sine, so that's sine 2 theta. I got a 2 there, so I need to put a half in there, so my 1/2 becomes 1/4. And then the integral of 2 sine theta is negative 2 cosine theta. Alright, so now I can't leave everything in terms of theta. This is where I got to go back and substitute and get everything that I have back in terms of theta. So if I come back over here and redraw my triangle here just a little bit that I had to start off with, what I had with my theta there was that this was x minus 1, that was 1, and this was the square root of 1 minus, and then I had x minus 1 squared. So there's my triangle. Alright, so I can use some different things here to help me get to my final answer. So this is going to be just a little bit of algebra here. So I know that the sine of theta is x minus 1. So that tells me that theta is going to be the inverse sine, or the arc sine, inverse sine of x minus 1. So this becomes 3/2 arc sine of x minus 1, using my picture over there, minus 1/4 times, now, sine 2 theta. Use a trig identity. That's 2 sine cosine. So I can use my picture over there. So this is going to be 2 times the sine of theta, which was x minus 1, times the cosine of theta, which we found to be the square root of 1 minus x minus 1 squared. So there's 1/4 and 2 sine theta cosine theta, and minus 2 times cosine theta, which is the square root of 1 minus x minus 1 squared. It's a little ugly, but you got to do that. I mean, you got to go back and substitute everything in there that you have. All right. Now, first of all, a couple of things that I can do here to clean this up just a little bit. That's really all I got to do now is just clean this up. I mean, that's my final answer if you just left it like that, but we can clean this up just a little bit and make this a little bit nicer. So let me keep this in parentheses right there, x minus 1. All right, so we've got this 3/2. Sorry about that. Hit the cursor. So this is the 3/2 arc sine of x minus 1. So 1/4 and 2 gives me 1/2, so this is minus 1/2 times x minus 1 times the square root of 1 minus x minus 1 squared, minus 2 times the square root of 1 minus, and then I have a x minus 1 squared. Alright, so these two pieces that I have right here, they have a square root of x minus 1 squared in them. Sorry, they have a square root of 1 minus x minus 1 squared in them. Alright, so I'm going to factor that out. Plus, I'm going to factor out a constant here. So this is going to be 3 halves arcsine of x minus 1. I'm going to take out the half. So minus 1 half. I'm going to take out a negative 1 half. So I'm going to take out a negative 1 half times the square root of 1 minus x minus 1 squared. So if I take out that negative 1 half times the square root of x minus 1 squared, then what I'm left with is, with this first piece here, I'm left with just x minus 1 plus, and then if I take out the square root of 1 minus x minus 1 squared and I take out a negative 1 half, I need to put a 4 right there so that if I distribute it back in there, I would get back to the negative 2 times the square root of x minus 1 squared. Alright, and now we're done. We're home free. So this is 3 halves arcsine of x minus 1 minus, and then I have 1 half times the square root of 1 minus x minus 1 squared times, and what you have is you have x minus 1 plus 4, which will give you x plus 3 for your final answer. And that's as nice and neat as you can make it for your final answer there. So I know it's kind of a long, ugly example, but it illustrates a few things that I think are extremely important. So come back up here where we started, way up there. First of all, you've got to do the completing the square. You have to be able to do that. And then you've got to be able to recognize what kind of form that it fits for your trig substitution. And in this case, it fit an a squared minus u squared, which led me to label my triangle like I did over there, with my opposite side from theta being x minus 1 and my hypotenuse being 1, and that led me to everything else. And then you got to know some integration techniques. So you got to use some trig identities to help you rewrite some stuff, and then you make sure you take care of all 3 pieces in this integral. Make sure you take care of, like we did, x squared, the square root of 1 minus x minus 1 squared, and a lot of people tend to forget to take care of dx, but you're going to use what you called for x over there in your picture to help you take care of dx, because you've got to get everything in that integral in terms of theta. And then don't forget your final answer, you've got to get everything back in terms of x, so you're still using your triangle to back substitute and get everything back in terms of x. Like I said, I know it's a long example, but I hope it illustrates a lot of different things, and I hope it helps you with your homework and stuff.